Hello everyone, and welcome to my YouTube channel again. Today I'm going to be talking about Apache Beam and walk you through some of its features. But first, let's try to understand what it is. And so Apache Beam is basically a unified programming model through a single consistent API, which is designed to define and execute both batch and stream data processing pipelines, and it abstracts the underlying execution engine, and allows developers to focus on writing the data processing logic once and run it on multiple backends. It supports various features for data processing, such as transformations, triggers, windowing, and more. Let's see some of those in action. So quickly, some of the first few steps would be to install Apache Beam using the pip install command, and then followed by that we'll just import like Apache Beam and some of its relevant features through these import commands. And once that is done, we'll just quickly load our data as well. So in this use case, I'm using the bank marketing data set. And yeah, so I mean, I just got that from Kaggle if I'm not wrong, but and yeah, once we load it into the data frame, we're able to start with exploring these features now. So up first is composite transform, but before we go into that, let me explain P collections to you. So P collections, or P call, as you can see here, is a it represents the distributed data in your pipeline. And if you have, say, 100 rows of data, for instance, it is transformed into P collections and split into chunks for parallel processing. So with composite transform or any regular transformation pipeline, those chunks go through the process, the transformation process, in a parallel fashion. And as we can see in the cell here at the end, you can see, so we have three phases: create data, pre-process data, and print data. In the first phase, we use the Beam's create command here. And what it does, it creates, converts the input data frame into P collections. And now that the P collections is ready, we pass it to the pre-process data phase. And yeah, so here we have actually defined our transformations. So all encode education and marital status are both individual transformations. As you can see, these are static methods which just transform a categorical column into a numeric column using some transformation logic. So what this does is using map method here, uh, it creates a transformation pipeline which combines these to create a composite transform, where both of these rows for these particular two features will be transformed individually. Yeah. And ultimately, after that transformation is done, last phase is print results, where again it just calls the print method, and all it does is it prints all of the responses it got from this after the transformation. So just look at it like, what we transformed was education feature and marital feature. So if you look at it, marital and education are now 1114, similar to that. So it has turned into numeric, and that's exactly what we use the composite transform for. Okay, yeah. Up next we have quite a simple one. Yeah, which is the pipeline input output, which, I mean, as the name suggests, it represents the input output capabilities of Beam. And here we have basically defined a pipeline which reads from the CSV file and parses the data using the map method, which is defined here above, the parse CSV method. And all it does is it extracts like the age, job, marital, education, and subscribed information from the row. And once that is done, we have applied some filters additionally. So it uses the filter method from Beam. And the first filter, which is filter none, is basically just like if the data is none, or which is the null equivalent of Python. If the data is null, it just skips it. And the second one is if we want to get all the subscribed customers from our data set. So it just filters all the subscribed customers from it. And finally, at the end, this data gets formatted and written back into CSV. So for this particular case, beam.io read from text and write to text is exactly what this thing, I mean, exactly what this provides. Like it, instead of doing the whole thing in a long process, you can just use these read from text and write to text and update data in very small amount of code. Okay. Yeah, up next we have the window and trigger features. So windows, I'm sure some of you might know the words fixed windows and sliding windows. So windows break down the P collection into fixed logical size windows for batch processing. In both these scenarios, so as you can see, in the first one we use fixed window, and the second one we use sliding window. A fixed window is like just fixed size of 5, but a sliding window is like it would take, there's a overlap of 5 but the maximum size of 10, for example. So it would have like 0 to 10 but then 5 to 15, and something of that sort is how you'd build a sliding window. Okay, yeah, and basically what this code does is it aggregates the number of subscribed users, as you can see here, using count.globally, and displays it using both using these window methods of processing. And another thing is like we are also using triggers here. So triggers, on the other hand, determine when the results of a window is emitted in this case. And here we have defined it in the same way using after watermark and after count. And both of these are combined together to build a very basic pipeline, but this is obviously a very simple example, and windows and triggers can be used for a lot more complex use cases with appropriate batch size, where it shows the correct response. Um, Correct response might have been the wrong term. Correct response you might still get, but what I mean is a more appropriate size would show its functionalities better. Yeah. And next up is the Pardo feature, which processes each element in a P collection independently. So as you can see, we're calling Pardo here, and we're using encode loan data, and this do function also helps us define it as so. And yeah, so what it does is it allows us more fine-grained control over our data transformation, which helps if the logic is more complex. If the logic requires multiple steps and more flexibility with the outputs, the Pardo is far more favorable than transform. In this case, we pass the data again through this pipeline, creating the P collections, and we use it to encode the housing and loan features into binary data, as you can see. And yeah, I mean, finally we just print it out. So as you can see on housing and loan columns, it's like 0010 and similar to that. It's now converted into binary instead of using yes or no. Okay, and the last feature I actually want to talk about is streaming. So to show how it supports stream, we define a simulate stream method here, which what it does is it basically sends the rows at a 1 second interval. So it would simulate like a stream where the data is coming out and uh, I mean regularly, right? So in this case, what we do is we follow the same steps as usual, but pass the data in a stream format. And each data point is sent through the filter subscribe phase here. After the simulate stream has sent the data in like 1 second interval every time, it's able to then, apply the filter on each of them individually. And finally, using windows and triggers, we are able to emit the data. And so in this case, really, we just print the element along with the timestamp. So as you can see, it prints all the subscribed ones, but it has different timestamps, which you can see about like a couple seconds away. Yeah. So this is how streaming works as well. And yeah, so these were some of the basic features of Apache Beam, and hope these will be useful to you in your data science projects. Thank you for watching, and I'll hopefully be back.